talked about 4 or 5 hours into the night, and I realized that, my answer was a little dodgy. I didn't really have a way to put it succinctly. So I thought, I need to write this down, because when you're right, it forces you to be precise. It's easy to speak in foggy language, but you can't write, these good sentences in foggy language. It doesn't work. So it tends to make you clean up your act. So I did, and that's what these books came out to be. Now, writing the books was a little different. The first time I wrote it, it was 8 pages long. And I passed it around to people, and they looked at me and shook their heads and said, "What does this mean?" So I said, "Well, what's the matter?" So they asked some questions. So then I'd write more to answer their questions. Then I'd send it out again, and they still didn't get it. So I'd write more to answer their questions. And eventually I ended up with about 840 pages, at least. It was about, the very first printing, it was almost 900 pages. It was like 897 pages or something. So it just grew. And partly because I struggled to make it understandable. That's the hard part. You have these experiences, and that's one thing, but communicating them to somebody who's never had these experiences so they understand it, that's really tough. So it took me 5 years to write the books, and of course I had a full job at the same time, but I probably was putting 30 hours a week on writing the books as well as 40 hours a week in a job. Finally, it got done. We put it out there, and my experience with publishers is that, well, sure, it looks like it's pretty good, but we need to cut this thing down. We need to get it down to about 200 pages. And what do you want? Do you want to be touchy-feely and then a kind of new age thing, or are you doing science? Don't try to do them both. And this kind of stuff. They needed a book that would sell. That was their point, and I needed a book that said what I wanted it to say. So then I went my own way with it. Decided it would just take time, it would be viral. I just set up a web page and just see what happened. Well, at least it got me here, right, to Hawaii. It couldn't be all bad. So that's kind of where it came from. It's still really new. Now what happened was that I wrote the book, and then after I finished writing it, I decided I'd do the research that, of course, you always do before you start writing. At the end, I said, well, let's do the research and see if anybody else, thinks any thoughts along this line. And I was surprised. I found that some physicists, about 10 years earlier, Dr. Edward Fredkin, had presented a paper about the world, our reality, is a virtual reality. Time comes in discrete pieces, space comes in discrete pieces. It's all a simulation and digital. I said, right, I verified what I was thinking, and then I read another paper by another scientist that was saying the same kind of thing. So then I found out that, hey, science is coming along in this same way. And then I ran into Brian Whitworth, who wrote a paper, and then said, well, let's just look and see, which one of these two concepts does the better job at answering answering what we know about physics. So here's this, reality is digital and virtual, reality is objective, which is the traditional idea. So he wrote a paper. These are all published, peer-reviewed, papered in scientific journals, and his conclusion at the end was, listen, physicists, this virtual reality is a much better model. Answers the physics better. Has fewer problems, answers more of the questions. This one has a lot of problems with it, things it just can't answer, things that just don't make sense. So that was actually just before I published the book. I found that out right at the very end after I'd written it. And then I started thinking about what it was I had done and looking at it kind of anew from a scientific, scientists are taking this. I thought it was science, but I was probably the only person in the whole universe that thought it was science because I had done the research. I was the only one that knew the quality of the research that had gone into it. So I knew that it was real and logical. But no one else did. So then I started thinking in terms of science. I said, well, this does apply. So where am I missing the point? It's almost all metaphysics and philosophy, because it all came from my research in that body. So, but it needs to connect better. It was logical, and it was science, just like any scientific theory. It started from a couple of assumptions and went to the end of the conclusions. But I needed to tie it into physics the way physics is today, what people think. So with a little bit of thought and a little bit of nudging and good luck here and there, I realized that what I had done already derived and solved two of physics' most significant problems that the traditional physicists are stuck with. One of them is, why is the velocity of light a constant? And the other one is, why should particles be probability distributions? Okay, the first is the basis of relativity theory. Once you know light's a constant, relativity theory is an algebra problem. Once you know particles are probability distributions, quantum mechanics is just a math problem. Those are the two major ideas behind that. Now, physicists today had no idea why light was constant or why particles should be probability distributions. They just know that if you assume that, you can calculate the right answers. So that's the way it is with quantum mechanics. One of the best productive pieces of science in probably forever. But no one knows why it works. All they know is it's a mathematical formalism that if you apply it, you get right answers. Absolutely no idea whatsoever why it ought to be that way. Same with relativity. No idea why C ought to be constant. Nothing else is. So I realized I had the answer for that my big toe, if you will, theory derived both of those things. And then it started deriving other things too. Once I saw the pattern, now this is after I'd already published the book, I'm starting to put things together, which is why my talks do more than what's in the books, because I've learned a lot all the time. I keep learning things all the time. And then I realized that things like synchronicity fell right out of it as well, explaining how does that work? How does that work that you just happen to do this, which bumps you over here to do that, which, and then suddenly it ends up in some wonderful prize you get at the end. You meet or make some connection that's pivotal in your life, and you just see all these strange things that led you there. That's kind of synchronicity, and now that makes sense. And then the things where Dr. Tiller is having the pH of water raised. He takes a beaker of water, pH around 7, and he has somebody use their focused intent, and after some time they can make the water change its pH a whole unit from 7 to 8 or from 7 to 6. And any of you know much about pH, that's a huge change. That's not a subtle change. A subtle change would be like in a third decimal place. This is a whole unit.
What does he do to get the water to change the pH?
Uses focused intent.
Just his mind.
Just his mind.
Nothing physical.
Nothing physical. Nobody touches it. Sealed beaker of water. Nobody touches it.
And that's been documented?
Documented. Yeah,
he's done this. Literature?
He's done this. Well, he has published it. He's put some of his stuff up on YouTube. Okay. He's done it over again. He's done it in front of other people.
I'd like to.
What happens? Well, we'll get into a little bit more. So anyway, Dr. Tiller is doing that, but of course, Dr. Tiller doesn't know why it works either, other than intent modifies reality. How does that work? Well, then all that falls out in this theory as well. There's a Japanese fellow who freezes water. And when you freeze water, there's a lot of uncertainty of how it freezes. No two snowflakes are the same. So he uses his intent, and he freezes the water, and he thinks happy thoughts. He gets water that freezes in pretty little crystals. He uses unhappy thoughts.
He uses his mind to freeze the water?
This
is his mind to freeze the water?
No, he doesn't use his mind. He freezes the water, but he uses his mind to send good energy or bad energy to the water as it freezes. If he uses good energy as it freezes, he gets pretty crystals, very symmetric. If he uses, a bad attitude, terrible thoughts, things he doesn't like, then the water freezes in these ugly globs. So, of course, it turns out that this theory in my big toe answers exactly why that happens too. You have your mind influences the probability of what happens next. Now, that's kind of the bottom line. But let's go, let's pursue this a bit. And I'm going to back up and kind of, now that we get to the bottom line, we'll go back and kind of build up to that later. Then think of some other things that work that way. What about the placebo effect? Placebo effect is where you give somebody, the real pill and the sugar pill, but you tell them both the same thing, and what do you find out? You find out that the person with the sugar pill, the placebo, the fake pill, about 35% of them actually get better. And not that they think they're better, it's not just a mind trick, they really get better. Matter of fact, that's how medicine has to pass the test to be able to be marketed in this country is that you have to beat the sugar pill. You have to beat the placebo effect. And that's been getting harder and harder and harder. Matter of fact, they take some of the medicines that did beat the placebo effect 15 or 20 years ago, and they don't anymore. It's getting more difficult. So how does that work? Well, that's just intent, right? Somebody has the intent. Oh, this is going to, it's a terrific new pill. It's magic. You're going to get a lot better. Well, that person starts thinking more positively. Positive intent changes the probability of what's going to happen in the future. Okay. What about prayer? Right? Works the same way. Positive intent can change the probable future. What about, you've heard of this law of attraction thing? Same way, positive intent changes what happens in the future. Okay, so all these things sort of work that way. There's another one called reverse causality. Reverse causality was first done by some rabbis in Israel. They got a bunch of records from people in a hospital. These are old records, decades old. People have been in the hospital, got out a decade ago. But they had all these records that they got at the hospital. They broke them up into groups, and there was a control group and an experimental group. The experimental group, these rabbis sat around, and other people, I think it wasn't just rabbis, but people with ability to focus their intent. They wanted these people, not the control group, but the experimental group, to have better health, be healthy. Okay? And what they found then when they did the statistics was that the group that the rabbis had prayed for and used their focused intent on had statistically significant shorter hospital stays. And it's like, oh my God, how did we do this? This is old data. These people were already in and out of the hospital. How could we change the average hospital stay if something happened 10 years ago? So that was called reverse causality. And my explanation, or my big toe, explains exactly how that works. The short of it is that the data was still in the future as far as what the probability or what the average length of hospital stay was. That was still in the future. Nobody had done these statistics before. The data was just there. They just took it out of old patient data. Nobody had analyzed the data. So that was still in the future. Focused intent modifies the future. Now see, this is a big one. What does this tell us? It tells us that reality is not objective. Because what the data says and what actually happened don't have to be the same. In an objective reality, those two have to match. You can't have what happened and the data that described what happened being different. Well, we don't live in an objective reality. We live in a statistical, probabilistic reality. And of all people, physicists should know that because they're the ones that came up with the quantum mechanics that says the particles of which everything else is built only exist as probability until a measurement's made. That's the basic foundation of quantum mechanics. Okay? Particles are just probability distributions. And when you make a measurement, that probability distribution, which physicists call the wave function collapses to a physical particle. So they understood that there was no matter, there was just probability distributions. So it should not be a big surprise that our reality is basically non-objective, it's probabilistic and statistical. Now there's a lot of theory. I'm just skipping through things that would take days to derive for you or whatever. These are the kind of the bottom line results.